Hi all. Today I am going to present my work based on copper bismuth iodide thin film with a switchable photosensitivity. We know that perovskite material are well known for their excellent performance in solar cell and photodetector. Basically, efficient perovskites are made using lead. We know that lead is toxic. So also, this perovskite material are difficult for synthesis. It need a glove box setup like that. So here we are introducing a class of lead-free perovskite material called rhodophyte, which is copper or silver bismuth based material are known as rhodophyte, having a general formula of AX X plus 3Y, or X is a halogen like chlorine, fluorine, iodine. Here we are using A site as copper and B site as bismuth and X as iodine. Coming to the material aspect of this material, this material is having a promising property like it can lead a good photo detector, and also it is most favorable for the optoelectronic application. It is non-toxic and environmental friendly. Also, we can have a direct band gap. Normally, the direct band gap of this material is varying from 1.82 to 2 electron volt. And also our synthesis method is also very promising and very easy method as compared to other perovskite material. Here we are using chemical back deposition followed by iodization process. That is, first we will make the precursor thin film of copper bismuth sulfide. Then we iodize for 6 and 10 minutes, and we will get direct thin film of copper bismuth iodide. Which is a quality film we are getting. Within a few hours we are getting the thin film. And also we study the characterization by XRD for analyzing the phase and the stoichiometry of the material. First we analyze the copper bismuth sulfide and we code it is an orthorhombic phase having a stoichiometry of Cu2BiS2, and after that when we iodized and obtained the film of copper bismuth iodide, and we analyzed on XRD, it obtained that cubical phase having a stoichiometry of CuBi-I4, and for confirming the phase we did Raman analysis, and we got 3 active Raman, and we confirmed that it is in the phase of CuBi-I4. And EDAX also did. From the EDAX also we can see that sulfur is, as the iodization time increases, sulfur is replaced by iodine completely. That is the complete formation of the material. It implies XPS study was done. From the XPS study, we obtained that the copper is in the plus 1 oxidation state, bismuth in bismuth 3 plus, and iodine in I minus. And coming to the morphology, for the morphology of copper bismuth sulfide, we obtained that is a spherical morphology. When we iodized and completely converted that film to copper bismuth iodide, for the 6-minute and 10-minute granule morphology we obtained. As the iodization timing increases, the grain size of the material is changing. Then UV visible spectroscopy was done. From the UV visible spectroscopy for the for the copper bismuth sulfide, the band gap obtained was 1.42, and for the iodized film, its band gap varied from 1.62 to 1.10 electron volt, which implies that this material is completely detecting near IR. And also photodetector properties like photoresponse we measured using white light. Here we observe one change, that for the normally for copper bismuth sulfide we are getting a normal response by applying a biasing voltage of 0.5. For the material of copper bismuth iodide, we obtain that as we apply a positive voltage, the response is negative response. The opposite response we are getting, as when we apply a minus voltage, we are getting a positive response. This is known as the flipping property of the material itself. As for both ionization time, this material exhibiting the same property. This may be due to the crystalline defect of the material. Also, photodetector parameter was studied, and photodetector parameter, the sensitivity of copper bismuth sulfide, it was 41.72, and for this flipping property, due to this flipping property, the sensitivity of the material is changing, and we are getting the negative sensitivity. Okay, then the stability study was done. Stability study. This material is stable for more than 20 days. There is only a slight difference in the intensity of the UV visible, and also from the EDAX also we observe that there is a slight change only. This implies that this material is completely stable material, and it is a promising candidate for the photodetector application. And here for the conclusion, we have successfully fabricated the rudolphite material by a simple technique called chemical bath deposition, followed by iodization process, and all the analysis was done, and band gap obtained was 1.64 to 1.10 electron for the copper bismuth iodide. And also morphology, coming to the morphology, there as the iodization time increases, morphology, the grain size of the morphology is changing, and this material is stable under the abundant condition, and the photodetector property, that is flipping property, was found.